Our topic is higher order differential equation and today's our case is 3 in which a function of x is equal to x to power m. Now our goal is to find a complete solution and a complete solution is equal to complementary factor plus particular integral. Our complementary factor is equal to c dot f and particular integral is equal to p dot I. Our complementary factor is equal to yc is also denoted as yc and particular integral is also denoted as yp and our equation for complete solution is y is equal to yc plus yp. Now our example for case 3 is d square plus 5d plus 4 into y is equal to x square plus 7x plus 9 and this whole equation are is function of x. Now our first step is to solve our equation for yc. Therefore we reduce our equation into homogeneous form and keep our constant is equal to 0. Therefore we can solve for yc and our next step is to make an auxiliary equation which is d square plus 5d plus 4 is equal to 0. Therefore we can find our roots for yc. Here for finding our roots for yc we just use a middle term breaking and then just taking our commons and finding our answers and the roots of our equation is lambda is equal to -1 and lambda is equal to -4. Here now we can see that our equation is of second order differential equation. Therefore we have obtained two roots. Now we can write our equation for complementary factor which is yc is equal to c1 exponent a1x where a is our root of the equation, one root of the equation, and c2 exponent a2x is our second root of the equation. Now our step 3 is to solve our equation for particular integral and the formula of particular integral is yp is equal to 1 upon function of d into s to power m. Now we can write as yp is equal to 1 upon d square plus 5d plus 4 into x square plus 7x plus 9. Now our step 4 is to take out the lowest degree term from function of d to make the first term 1. Now here our lowest term is 4. Therefore we take it out as a common and therefore our equation is now look like this: 1 upon 4 bracket open 1 plus bracket open d square upon 4 plus 5d upon 4 bracket close and bracket close minus to power -1. Here we are making our formula of binomial theorem just like this: 1 plus x. Now this is our x into function of x. Now what is our binomial theorem formula? Our binomial theorem formula is 1 plus x to power -1 and when we expand our formula then it will be just like this: 1 minus x plus x square minus x cube and so on. Now step 5 of R is to apply binomial theorem up to when d power m plus 1 and s to power m is equal to 0 or d power m plus 2 and s to power m is equal to 0 and so on. Now our equation of yp would be just like this: yp is equal to 1 upon 4 1 minus bracket open d square upon 4 plus 5d upon 4 bracket close plus d square upon 4 plus 5d upon 4 and bracket close x square and d minus Now this is our expanding of the formula, and here you can see that d square upon 4 plus 5d upon 4 is a value of x, and d square upon 4 plus 5d upon 4 the whole square is the value of x square. Now our step is 6 is to expand our entire formula. Therefore our equation would now we just expand our whole formula, and our next step is to multiply a function of x to the entire formula. Therefore we just multiply our function of x to the entire formula, and now our step 8 is to derivate our whole equation. After derivating our whole equation, our particular integral is equal to 1 upon 4 x square plus 9 upon 2 x plus 23 upon 8. Now this is the answer of our particular integral. And now our last step is that we had find our complementary factor and a particular integral. Therefore our goal is achieved, and we had find a complete solution. Now what is the equation of a complete solution? Now y is equal to c1 x to the power minus 1 plus c2 exponent minus 4x plus x square upon 4 plus 9 upon 8x plus 23 upon 32 is our complete equation, and it is our final equation. It is the answer of our example. Thank you.